Python is a very crucial tool for aspiring data professionals. So welcome back to the channel and welcome back to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. And today is day 7. We're going to continue from where we stopped on day 6, where we actually looked at the Matplotlib or package in Python, which is used for creating meaningful and insightful plots in Python. So on this live stream, on the last live stream, actually, we learned all about the line plots and the scatter plots in Matplotlib. Today, we'll be looking at how to plot histogram in Python. Then after that, we'll be looking at customizing this plot to make them readable and visible to the eye. Well, they're quite visible actually to make them readable and insightful to the eye actually. If I just really quickly launch my Anaconda Navigator real quick here. So I'm going to show you what we've done on the last live stream so far, so we can continue from there today. So also all data sets, Power BI files, sorry, not Power BI files, not Power BI, Python files actually, and CSV files that we'll continue to be using and we'll be using is already linked under the YouTube description. So do make sure to download those files and practice along with me. So without further ado, let's jump back to learning and welcome back to Python day 7. So if you're looking to catch up on previous live stream, I will encourage you to go to the live stream tab on the channel because over the past 6 days, we've got introduced to Python, starting from variables and data types in Python. They will move down the ladder to today. So if you are new to the channel, my name is Sheriffdeen Abatan. You can call me Sheriff for short actually. So I'm a top rated plus freelance data analyst on the Upwork platform. So I'm currently looking to upskill myself and gain some competitive advantage in the data professional industry. So when I started this fun way of learning, it actually started with data analysis in SQL, which we did for a period of 100 days. This was the longest. So we did data analysis in Power BI also, which went for a period of 69 days actually. Yeah. So we are looking to complete Python in 100 days target also. So hopefully we won't exceed the 100, or probably we're going to complete the whole course and lessons and practice that is in this track before day 100. So I click on this real quick. Oh, my Anaconda Navigator is up. I'll just launch my Jupyter notebook. So if you're looking to install this Anaconda Navigator, which will give you access to every Python environment you'll be needing throughout this learning journey, just go to day 1 and watch the live stream of day 1 where I showed you how to install and have access to this Anaconda Navigator, which you are going to have all the Python EDA or ED, I can't remember what they're actually called properly, or Python environment in general for you to code and start uh, analysis in Python. If I launch it, it is going to launch uh, the Jupyter Notebook interface on my web browser. So once it does that, I'll just navigate to where we stopped on day 6 so you can see what we've done so far. So I go to data sets here, intermediate Python, open this Python Jupyter Notebook file. So you can see that on day 6, we started by importing our packages. Then we connected to our data sets. So I've dropped these data sets in the link under the YouTube description. So do make sure to download so you can practice all this with me. So overall, we started plotting some columns, some variables from our data sets. So first plot we did was a line plot, which wasn't the best chart to us to visualize the data points that we actually pointed at. Then we move to using a scatter plot, which is a good representation of the chart we should use for those two variables we're actually trying to compare with each other. So that's what we did on day 6. So we're trying to also add histogram. Let's learn how to visualize histogram in Python. Then finally, we'll be looking at customizing the labels, the x-axis and y-axis, and giving it data labels to make it more meaningful and insightful to the eye. So that's what we'll be doing on today's live stream. So I click on, so we've done, so on this chapter, this intermediate Python. So we started with introduction to Python, which covered Python basics, Python list, function and packages, and introduction to NumPy. So go watch all of this on the live stream tab on the channel. So we just continue from this Matplotlib, and this intermediate Python has or contains 5 chapters you could see. Yeah, but finally, we'll be rounding it up with a case study, trying to put all what we've learned so far into action and good use. So let's continue immediately without further ado. Okay. So we stop at basic plots in Matplotlib with line plot and scatter plots. So we're looking at histogram today on how to build this in Python. Then finally we'll be customizing our charts and make it more interpretable.
Oh, you are killing it. Now, in this video, I'll introduce the histogram. The histogram is a type of visualization that's very useful to explore your data. It can help you to get an idea about the distribution of your variables. To see how it works, imagine 12 values between 0 and 6. I've put them along a number line here. To build a histogram for these values, you can divide the line into equal chunks called bins. Suppose you go for 3 bins that each have a width of 2. Next, you count how many data points sit inside each bin. There's 4 data points in the first bin, 6 in the second bin, and 2 in the third bin. Finally, you draw a bar for each bin. The height of the bar corresponds to the number of data points that fall in this bin. The result is a histogram, which gives us a nice overview of how the 12 values are distributed. Most values are in the middle, but there are more values below 2 than there are above 4. Of course, we can use Matplotlib to build histograms as well. As before, you should start by importing the pyplot package that's inside Matplotlib. Next, you can use the hist function. Let's open up its documentation. There's a bunch of arguments you can specify, but the first 2 here are the most important ones. X should be a list of values that you want to build a histogram for. You can use the second argument, bins, to tell Python into how many bins the data should be divided. Based on this number, hist will automatically find appropriate boundaries for all bins and calculate how many values are in each one. If you don't specify the bins argument, it will be 10 by default. So to generate the histogram that you've seen before, let's start by building a list with the 12 values. Next, you simply call hist and pass this list as an input, so it's matched to the argument x. I also specified the bins argument to be 3, so that the values are divided in 3 bins. If you finally call the show function, you get a histogram. Histograms are really useful to give a bigger picture. As an example, have a look at this so-called population pyramid. The age distribution is shown, for both males and females, in the European Union. Notice that the histograms are flipped 90 degrees. The bins are horizontal now. The bins are largest for the ages 40 to 44, where there are 20 million males and 20 million females. They are the so-called baby boomers. These are figures of the year 2010. What do you think will have changed in 2050? Let's have a look. The distribution is flatter, and the baby boom generation has gotten older. With the blink of an eye, you can easily see how demographics will be changing over time. That's the true power of histograms at work here. Now, head over to the exercises to experiment with histograms yourself.
Okay, so on histogram, the 2 most important are the x and the bins value. The x is a list or your variables you want to plot. Then the bins is the number of segments you want your histogram to be. So build a histogram. So life expectancy, the list containing data on the life expectancy for different countries in 2007 is available in your Python shell. So if you actually loaded that, you can see we have our life expectancy here. Let me go back a little bit. You can see we have population already. We have GDP per capita here. Then we have our life expectancy here. So this is from our data set here. This column there. So we just turned them into an array. Then we made them into a variable. Quite easy. So the first thing was turning them into a variable, from a variable to an array. Then from an array, you can actually access this particular columns within a large bunch of columns in your data set. That was how this was done. Okay, so let's continue. So we just continue from there. I probably need to run each of this line of code one more time. So let's continue. It says to see how life expectancy in different countries is distributed, let's create a histogram of life expectancy. So import matplotlib.pyplot is already available as PLT. To create a life expectancy data, let's see. So use plt.hist to create a histogram of values in life expectancy, or the values in life expectancy. Do not specify the number of beans. Python will set the number of beans to 10 by default for you. So we're going to say plt ist. So now our value is going to be our life expectancy, life underscore exp. Then I'm going to show plt dot show. So let's see it in action. Voila, you can see. So the life expectancy for our data set. So I'll just go to my Jupyter notebook real quick and run the same code. So I'm going to run this shell again from scratch. So you can see that all of them are working fine. Voila. So we are now here now. So since I have my life expectancy as also life expectancy here from the previous live stream, you can see it here. So I'm just going to copy this real quick. Control C. Then I'm going to say, then I'm just going to look at the code from here also. plt.ist. Let's be plt.histogram. Since we are not specifying the number of beans, so I'm just going to leave it as default. You can see it here. You can see the array here. You can see that we got the same. You can see the same thing, just that there are no lines. You can see this one. There are like lines that separate each bars, but on the shell here, on the Jupyter notebook here, there are no lines. But you can actually differentiate. Probably there's a way to add lines to it here also on Jupyter notebook. We are going to see how to do that all later. So let's move on. So can you tell which beans contain the most observation? The beans that contain the most observation is this 71 bean, 71st bean, exactly. Now let's continue. Now build histogram 2 beans. So in the previous exercise, you did not specify the number of beans by default. So Python sets the number of beans to 10 in that case. So the number of beans is pretty important also. So too few beans will oversimplify reality and won't show you the details. Too few beans will oversimplify reality and won't show you the details. Too many beans, okay, will overcomplicate reality and won't show the bigger picture. So if you want to specify the number of beans, just a moment there. I think the most important thing is to specify the number of bins. So to control the number of bins to divide your data in, you can set the bins argument. So that's exactly what you do in this exercise. You'll be making two plots here. The code in the script is already in, the code in the script already includes plt.show and plt.clf. Course. What does hold on a minute? Oh, Queen, I only have a few windows open. Those are the stuff I use basically almost every day. So I just have them open like almost 2, 3, 4, 5 years now. I have all those windows open and I quickly track them. Oh, Opamini has a way of tracking your windows right here. You can actually search for the window that you need. So that's how I handle it. All right, thanks. I'm actually using Chrome browser. So Opamini has a feature like that also. So you can actually track. I'm actually using an extension called One Tab where I could actually track all my windows I have open and I can easily search for the one I want and just navigate to it pretty fast like that. So that is by the way. So that's exactly what you do in this exercise. So you'll be making two plots here. The code in the script already includes plt.show. Quite familiar with plt.show. We were not definitely familiar with this plt.clf or cliff. Okay, so plt.cliff calls plt.show, displays the plot. Plt.cliff cleans it up again so you can start afresh. Okay, show and clean up again. As before, life expectancy is available and matplotlib plot is imported as plt. So build a histogram of life expectancy with 5 bins. Can you tell which bins contains the most observation? I'm going to say plt ist plt dot histogram. We're going to paste in the life expectancy, live underscore ASP. Okay, but this time around, we want to specify the number of bins to be bins equals to 5. Okay, now let's see it in action. Oh, okay, build histogram with 20 bins. I haven't run this code. Show and clean up plots. Okay, build another histogram of life expectancy, this time with 20 bins. Is this better? I just copy this real quick and build this with 20 bins. Let's call it with 20 bins. Let's run the code. Oh, which one is it showing? Is it the 20 bins or the, let's see the previous plots? Previous plots, previous plots. This is probably the one with no bins, I guess. These are like 5 bins. 1, 2, 3, 4, 5. 5 bins. This one, no display. 1, 2, 3, 4, 5 bins also. And this is the one with the 20 bins. 1, 2, 3, 4. So this one is the 20. This one is like the 20 bins. So that is the 20 bins. Yeah. So let me run the same code here on my Jupyter notebook. If I go to my Jupyter notebook real quick and paste the same code, let's see it in action. You can see this is one of 5 bins. 1, 2, 3, 4, 5. And this is one of 20 bins. We could actually guess which one is much more better between the two, probably. But let's continue. We're going to differentiate Which one is giving more information between the two? When you look at it, the one with the 5 bins at bin number 70. You can with this bin number 70 and look at bin number 80 here. You can see bin number 80 here. But bin 71 has more observation compared to bin, probably bin 71 here also. Almost the same thing. But let's continue with the instruction. Let's submit the answer. Now you can see that the button to browse to the different plots you've created. Okay, the cliff button to browse to different plots we've created, but they didn't explain what the cliff is doing here. The code is the script already includes plt.show and plt.cliff. Pause plt.show displays the plot, cliff cleans it up again, so you can start afresh. Okay, that's way though. I haven't comprehended that part of the code pretty well though. But let's continue for now. Okay, so build a histogram, compare. In this video, you saw population pyramid for the present day and for the future. Because we were using a histogram, it was very easy to make a comparison. So let's do a similar comparison. Life expectancy contains life expectancy data for different countries in 2007. You also have access to a second list now, life expectancy 1950. Ooh, but personally, I won't have access to that life expectancy 1950 here. So this data is only for the year 2007. So this part of the course, you may not be able to practice it since they are trying to compare two life expectancy variables. So containing a similar data for 1950, can you make a histogram for both data sets? You will again be making two plots, plt.show and plt.cliff commands to render everything nicely already included. Also, the plot is imported for your PLT. And that's to build a histogram of life expectancy with 15 bins. Histogram of life expectancy with 15 bins. So I'll just say PLT dot is open brackets live underscore ESP. Then the bins, number of bins should be equal to 50. Build a histogram of life expectancy 1950 also with 15 bins. Is there a big difference? Okay, the other one, I'm just going to copy this real quick. But what we're showing is for the 1950 value, 1950. Okay, let's run the code and see. So the first one should be, okay, let's see. Let me just select this code. I'm going to select this bunch of code here and run it first. This for our normal bin, life expectancy of 2007, you can see. What about for this one? This for the 1950, you could see. So I could just move. Okay, this plt.cliff is going to will allow me to move between each histogram separately, unlike the one we did here. You could actually see the two histogram in one visual, in one code when we run the code. Okay, you can see the one for 1950 here. 1950. While the one for 2007, so the 71 bins has more observation. 5. Okay. 40. So it is in 15, 15. So it is 70 plus 15 will give me the next bin. This is 75. So the 75th bin here has more observation. I think the way the bins are separated. That's quite funny though. So let's continue with our observation. So toggle between the created plots. Do you notice anything interesting? Of course. Let's go to the first bin. This is the first one. 2007 bin, and this is 1950 bin. Okay. Okay, let's continue. So choosing the right plot. So you're a professor teaching data science with Python, and you want to visualize access. You want to visually assess if the grades on your exam follow a particular distribution. What plot do you use? I'm definitely going to use an histogram for that. So you're going to see the number of observation for each grade. So excellent choice there. So let's continue. So you're a professor in data analytics with Python. I want to visually assess if longer answers on exam questions lead to higher grades. Longer answer on observed on exam questions. Longer answers. So okay, we are trying to solve this. Choose the right plot for this. Okay, if you are going to see longer answers on exam questions, so if the answers are longer, does it lead to higher grades? That's quite funny. Let's go for an histogram first. I know that would be wrong. That's quite funny. So that would be a scatter plot. So we're going to compare two variables. If the exam questions are longer, does the grade of the student get higher? So I'll go for a scatter plot here. Exactly. You can see there are two variables involved. You can see time to take the exam and the corresponding grades. So histogram is not a suitable option in this case. That's interesting to see. So let's talk about customizing our charts. So we've actually plotted all these charts you could see. So there are no data labels, so they are actually returning same color. You can actually change these colors of these charts to make it more visually appealing to the eye. So let's learn all about that in the next lesson.
Wow, now you've got histograms under your data viz belt, let's figure out how to customize our plots. Creating a plot is one thing. Making the correct plot that makes the message very clear, that's the real challenge. For each visualization, you have many options. First of all, there are the different plot types. And for each plot, you can do an infinite number of customizations. You can change colors, shapes, labels, axes, and so on. The choice depends on 1. The data, and 2. The story you want to tell with this data. Since there are so many possible customizations, the best way to learn this is by example. Let's start with the code in this script to build a simple line plot. It's similar to the line plot we've created in the first video, but this time the year and pop lists contain more data, including projections until the year 2100, forecast by the United Nations. If we run this script, we already get a pretty nice plot. It shows that the population explosion that's going on will have slowed down by the end of the century, but some things can be improved. First, it should be clearer which data we're displaying, especially to people who are seeing the graph for the first time. And second, the plot really needs to draw the attention to the population explosion. The first thing you always need to do is label your axes. Let's do this by adding the X label and Y label functions. As inputs, we pass strings that should be placed alongside the axes. Make sure to call these functions before calling the show function. Otherwise, your customizations will not be displayed. If we run this script again, this time the axes are annotated. Fantastic! We're also going to add a title to our plot with the title function. We pass the actual title, World Population Projections, as an argument. And there's the title. So using X label, Y label, and title, we can give the reader more information about the data on the plot. Now they can at least tell what the plot is about. To put the population growth in perspective, I want to have the y-axis start from 0. You can do this with the yticks function. The first input is a list. In this example, with the numbers 0 up to 10 with intervals of 2. If we run this, the plot will change. The curve shifts up. Now it's clear that already in 1950, there were already about 2.5 billion people on this planet. Next, to make it clear we're talking about billions, we can add a second argument to the yticks function, which is a list with the display names of the ticks. This list should have the same length as the first list. The tick 0 gets the name 0, the tick 2 gets the name 2b, the tick 4 gets the name 4b, and so on. By the way, B stands for billions here. If we run this version of the script, the labels will change accordingly. Awesome. Finally, let's add some more historical data to accentuate the population explosion in the last 60 years. On Wikipedia, I found the world population data for the years 1800, 1850, and 1900. I can write them in list form and append them to the pop and year lists with the plus sign. If I now run the script once more, 3 data points are added to the graph, giving a more complete picture. Now that's how you turn an average line plot into a visual that has a clear story to tell. Over to you now. Head over to the exercises, gradually customize the world development chart, and become the next Hans Rosling.
Interesting. So customizing your plot is quite easy. So let's see. So labels. We want to learn about adding labels, ticks, size, colors, and additional customization here. Then we're going to finally interpret our plots. That's interesting. It says it's time to customize your own plot. So this is the fun part. You will see your plots come to life. You are going to work on the scatter plot with world development data, GDP per capita on the x-axis, life expectancy on the y-axis. The code for this plot is available in the script. So as a first step, let's add axis labels and a title to the plot. You can do this with the x label, y label, title functions available in the PyPlots. This subpackage is already imported as PLT. So the strings xlab and ylab are already set for you. Use the variables to set the label for the x and y axis. Okay, xlab, ylab title. So plot.scatter, if you want to look at the scatter plot here. So they've converted the x scale for the s scale is for the DDP to a logarithmic scale. So the GDP has been converted to a logarithmic scale. We're going to add the axis label. So I'm going to say x label, open brackets. So it should not be add x label. So be plt dot x label. So for the x label, it's going to be our DDP, cap. I'm just going to put it in quotes. For the y label, plt dot y label is going to be our life expectancy. So add the title. So the title, the string title is also coded for you. Use it to add the title. So the title is going to be, hold up. So I'm supposed to call on the x label. So instead of calling on this DDP capacity and life expectancy, I'm going to use this x lab string. Oh, I'm going to call on the x lab string here. Okay, x lab. Then for the life expectancy is going to be y label. So they are there as a variable for me already. You can see the string x lab and y lab are already set for you. Use these variables to set the labels. So I'm going to use the variable from these strings there. The title also plt dot title is going to be this title label here. A title label. So after customizing, display the plots. So after this customization, finish the script with plt.show. Let's do plt dot show to see what we've done so far. Let's run the code for all I can see. So our world population in 2007 is this one here. Our Y label, is the Y lab, this life expectancy here in years. Then our X label is the GDP per capita. So let's do the same thing for this our chart here. This chart up here, this one here that we are seeing here. So we're going to run the same code for the chart also. So what I'm going to do, I'm going to copy this scatter plot here, everything. Control C, go to my Jupyter notebook here. Ooh, now let's see it in action. Voila, I can see. We run the same code and we're having the same results. So our GDP, this is our GDP per capita. We've done that from here earlier. You can see, this is our population, this is our GDP per capita here. This is our life expectancy from here. So I was able to run those codes because I have those data points already set. So what development in 2007? These are the life expectancies on the Y label. This is GDP per capita in USD on the X label. But why did they convert the scale here? This is our GDP per capita values to a logarithmic scale. But probably the numbers are pretty way long in billions, way long in USD. But that's interesting to see that we could actually achieve that also. Let's continue. Great. This looks much better already. Okay, ticks. So let's add ticks to the visual. So the customization you've coded up to now are available in the script in a more concise form. So the tick label. So the values for this label, the actual amounts. Okay. That is in 4,000, 2,000, maybe millions or billions. So we need to understand what those numbers are. So the customization you've coded up to now are available in the script in a more concise form. So in the video, Google has demonstrated how you could control the white ticks by specifying two arguments. So plt.white ticks to show 1, 2, 3. So in this example, the ticks corresponding to the numbers 0, 1, 2 will be replaced by 1, 2, 3 respectively. So let's do a similar thing for the x-axis of your word development chart. So with the x ticks function, the tick values 100, 1000, 100,000 should be replaced by 1k, 10k, and 100k. Okay. Okay. So to this end, two lists have already been created for you: tick value and tick label. Use tick value and tick label as input to the x ticks function to make the plot more readable. So we have our scatter plot already also here that has been dropped. So then the previous customization, the scale was converted to a logarithmic scale. The X label, the Y label, the title were have been put in a variable. Okay. Then the definition of tick value and tick lab. So tick value, adapt the ticks on the X axis. So you're going to say tick value. Let's see. It's supposed to be on the X ticks. So it's going to be our plt dot, let's see. So plt dot x6. So our x6 is our GDP per capita here. So y is the life expectancy in years. So the y label is the other one. So this one we're doing the x6. X6. So it's going to be I'll reference the tick value here. Going to be tick value. Then after customize display the plots, adapt the ticks on the x-axis. Okay. Okay, the tick value and the tick label. Okay. This value is different from the tick label. Then the label is going to be, okay, I'm going to mention this also like this. Hold up a minute. Let me open a bracket again. It's going to be tick label. Let's see. So we confusing at times. So PLT. It's going to be PLT dot show. Let's see. Ooh. And I know I'm going to get an error there. Let me see the one I did earlier here. The axis label. I just recommend flow to the thing that have been created for us. So I didn't need to put it in quotes. Do I need to put it in quotes? So let's see this in action. X6. So the error comes from the following part of the code. Adapt the tick to the x-axis. Okay. plt.x6. I'm not supposed to put them in different quotes. Okay, understood. Now let's see. Okay. Now let's run the code one more time. Aha, you can see now. So we nailed our error here. So what we could see now is that I can see the 1K, 10K, 100K has been replaced. So you can see the tick value is 100 on 10,000, then 100,000. That's the difference between the values there. And we use the tick label to actually replace those functions, those values. So let me see that in action. So let's see it in action here one more time. So you can understand what is happening here. What I want to do first, okay, before I do that, let me first of all, let me remove this one first. Ctrl Z. So you could have a much more better understanding. You can see my values there. And see in logarithmic scale, does this have definition of tick? I want to understand why I can't just show the values in 100,000. You see converting it to, okay, the log scale that we specified here. So to replace that with this, just come back, place that, and run the code again. Voila. You can see now. Okay. So I'm going to create the same thing in my Jupyter notebook here. Let's see. Let me copy this from here. So what I want to do first is to remove this tick label here. I just remove that on purpose and run the code. You see, so we're having almost the same result here. You can see same, not even almost, we're having the same result as earlier. But since the tick value from here for our GTP per capital is already specified. It is this our logarithmic scale here, still converting it to what? To logarithm. So I'm going to replace that with this value here. And for like I say, it got replaced already. So it's now in USD, not in logarithmic scale already. Since the logarithmic scale are converted to tens, let me just undo that one more time. Let's see. I see 10 raised to the power of 3, 10 raised to the power of 4, 10 raised to the power of 5. So 10 raised to the power of 3, that is 10,000. That is 3 zeros there. This should be 3 zeros. Then this means 4 zeros. And this means 5 zeros. You can see 10 zero, 3 zeros, 4 zeros, 5 zeros. You just replace that with this tick label here that has been defined in a variable here. This is much more better here. So interesting. Why it takes okay. So there's a comma there, okay. If you want to okay, you give your ticks another argument, they are going to use it to display it. Okay. That is understood right now. Instead of writing, I could have easily written all this here in this X ticks label. I could have easily written this and this and use a comma to separate them in this code. Just like I use a comma here. So we actually put it in a list to make it easier for us. Okay, that's interesting. Let's continue our challenge. Great, your plot is shaping up nicely. So we got that also. So finally, sizes. So we can just specify the sizes. So this is the size. Then color. We need to specify colors also. So far, they are seeing in the same color. You can see blue color, default blue color. So right now, the scatter plot is just a cloud of blue dots. So indistinguishable from each other. So let's change this. Would it be nice if the size of the dots correspond to the population? That's interesting. You can see based on the population that we have here, we don't know which population is higher. Probably the one at the edge. You can see the one that are going towards 100K. That means they have more population and their life expectancy is higher. Those one below here, less population and their life expectancy is short. Like this 40 between this 40 life expectancy, 40 years of life expectancy, and their GDP per capita is almost close to probably 8K, probably the 6K, 7K range. What if we make the dots to be bigger based on the population? And do you get it now? So that we want to do here with sizes. So to accomplish this, there's a list pop loaded in your workspace. It contains population numbers for each country expressed in millions. You can see that this list is added to the scatter method as argument S for size. Let's see. Let's see. Mm, Argument, you can see, okay, this S equals to population size. Mm. Update set S as argument to np underscore pop. You can see for our pop here, I have my population record here also. Just a minute. Oh, just a minute there. Okay, 1 second, real quick. I had no idea my mic was muted. So what I'm trying to do now is to hold up a minute. So we are trying to run the code here. You can see it says right now the scatter plot is just a cloud of blue dots indistinguishable from each other. So let's change this. Wouldn't it be nice if the size of the dots correspond to the population, as you can see here? So to accomplish this, there's a list pop loaded in your workspace. It contains population numbers for each country expressed in millions. You can see that this list is added to the scatter method. So I think the population sizes are expressed in millions. As you can see here also, the populations are expressed in millions. Let's see. You can see they're in millions. Exactly here. Okay. Now, the challenge I'm having now here is that so run the script to see how the plot changes. So if you just run this script, all these scripts together, you can see they've added the sizes as pop to the arguments, PLT the scatter, then GDP life expectancy, then the size for our bubbles should be what? The pop variable. If I run the code, we are getting this value as you can see here, just different color as you can see. So I'm trying to do the same thing for my own end here also, but I was getting this error because my size is equal to my pop also. I think what I could just do is, okay, let's start from the beginning. Let's run the whole code one more time. Now let's run this last code. I'm still getting this error. Oh, this is not fair. This is not fair at all, at all. It says S must be a scalar or float array-like with the same size. So it's saying this S must be a scalar. How do I convert my pop to a scalar value? Or it says or floats array-like with the same, or it floats. So a float is a decimal number of places. So we need to learn how to convert. How can I do that? Let me see. Can I get help on this error? If I can just paste this, is it possible for me to paste this error inside an AI to quickly figure out what is happening? Okay, I'm trying to see if I can troubleshoot this error real quick here. Probably using a co-pilot or something. Let me see. And this if I can just use. I'm trying to use so I'm trying to use Copilot to see if I can get the error to the code. Let's see. So I got this response from Copilot. Let's see it in action. Oh, almost same thing. Probably just find a way to troubleshoot this later. So I definitely need to run this part of the code though. So what I'm going to do is just paste it here. I'll come back to it later. And let's add a code below. So we're going to continue this part. I need to get what is happening there. This is not the code I want. So what I'm going to do is to copy this whole code from here. But let's see, sir. Let's leave that by the way and continue what we are doing. But it is actually working fine from the DataCamp feature here. It's not, it looks good, but increasing the size of the bubbles will make things stand out more. Import numpy package as np. Oh, okay. Let's import numpy. Numpy as np. Let's follow the instructions to complete this last part of the challenge though for now. I'll figure out why my own is not working in Jupyter Notebook. Use np.array to create a numpy array from the list pop. Call this numpy array np pop. Oh, probably because I've not specified the numpy array np pop. So it looks good, but increasing the size of the bubbles will make things stand out more. Import numpy package as np. Use np.array to create a numpy array from the list pop. Okay, a numpy array from the list pop. So we did that. Let's see how we do that here. See numpy array np.array that you mentioned the list that you want to use. So for this case now, we want to use the pop array. We want to use the pop to create a list. Okay. Now let's see. It says use np.array, top pop as a numpy array under np. It has to be np underscore pop equals to np dot array open brackets pop. For that, np underscore pop equals to np dot array underscore pop. So double the values in np pop, setting the value of np pop equals to np pop times 2. Okay, that would be np underscore pop times 2. So because np underscore pop is a numpy array, each array element will be doubled. So change the s argument inside plt scatter to be np underscore pop instead of pop. Now let's change this to be np underscore pop, np underscore pop. Okay. Now what next? Are we to run the code like this? Let's run the code now. Aha, I think that worked fine. I'm just going to copy this code and try it now in my Jupyter notebook. Oh, we spent an hour on the live stream though. Since we also converted our own np to np array, this is our pop. We converted to np pop. Let me just run the code here and see. Oh, we are still this. We are still getting the same error. I'm not using my s again here though. It's saying s must be a scalar or float array like with the same size as x and y. Why? Why are we getting this error though? There's no any other S value here. Do we change it to NP underscore pop? I still returning an error for same stuff. That's not fair. Okay, I'll just post this here also. Let's just paste that there and continue. We can see I made a mistake here. It says, did you correctly double NP by setting its value to NP underscore pop times 2? Of course I did. Let's see the help we're going to get from here. Okay, I need to point to SOOO. I need to say my size. Oh, my mistake was editing it here and saying, so my size, I need to maintain the size here. S is equal to, okay, let's run the code again. Okay, we got same results. So I'm going to say my S here, my size is got to MP pop here. Ooh, same error. Why? Why? This is not fair. This is not fair though. This is not fair. I can't seem to figure out the error now. I'll just leave it. Okay, let's submit. Oh, why? What's the problem here? Oh, just point. Okay, okay. NP POP double MP. So what am I supposed to point to? Okay, okay. Double the MP. If double the MP, you actually double the MP. So why are we not still getting this error? Sometimes you just continue getting error. Wow. I did the same thing though. So this is what I NP underscore pop equals to NP. Okay, double the NP. Okay, the mistake I did was I didn't look at my I said say NP underscore pop equals to 200. I need to make it a variable again here. That was my mistake there, you see? So that was my mistake there. So that was my mistake there. So let me now see this again in action. Let me see this again in action. NP underscore pop because NP from here times 2. So I'm pointing to this, say NP again, same error again. Ooh, this is not fair though. Same error again. Okay, let's continue though. Okay, this is not fair. So colors, we talk about sizes, but I didn't actually get the sizes challenge on my own Jupyter notebook here, which is not good enough because we did almost everything we needed to do. Okay, it says colors. So the code you've written up to now is available in the scripts. Okay, the next step is making plots more colorful. To do this, a list color has been created for you. So you can see a list color. Where is that? So we're not actually seeing the list here. It's a list with a color for each corresponding country depending on the continent the country is part of. So how did we make the list color, you ask? So the cap miner data contains a list continent with the continent each country belongs to. So a dictionary is constructed that maps continents onto colors. So a dict has been constructed. So Asia is red, Europe is green, Africa is blue, America is yellow, Oceania is black. Nothing to worry about. You will learn about dictionaries in the next chapter. Okay, interesting. So add C equals to color to the argument of the PO2. So we're now adding more argument to our scatter plot. Now we've added our X value, Y value, S is np.array. Okay, okay. Now add C. Okay, now let's add C. So color equals to col. Okay. Change the opacity of the bubbles by setting alpha argument to 0.83. So specify C. So specify C. Then finally the alpha arguments. So how do you specify alpha? You just say alpha. Alpha equals to 0.8 here. Okay. Alpha can be set from 0 to none, where 0 is totally transparent and 1 is not all transparent. Let's run the code. Voila. You can see. Oh, paint. I'm not getting this in my Jupyter notebook immediately. I'm doing it. I'm pained, really pained. But I definitely will figure it out. Okay. Okay. So we're able to specify this number of arguments for our scatter plot. Now let me now see if I could run this again for my own Jupyter notebook also and get the same results. Let me add a new code below here. Why is it kind of different? X is GDP underscore cap, Y is life expectancy, S is np.array, open bracket pop times 2, color, let's see, name color is not defined. Oh, okay, I didn't define my color. Look, imagine, seems the code is going to work here, but I didn't define color here. Now let me get rid of this color argument here. Let me see the next error it is going to bring. That same error as S scalar. Okay, good to know though. Good to know it's still going to bring that error for me. So what I'm going to do now is to definitely just paste that there, figure it out later. Nice. This is looking more and more like Ansgo slim plots. Okay. Now finally adding additional customization. It now says if you have another look at the script under additional customization, you'll see that there are two plt.test function now. They add the words India and China in the plots. Okay. Add plt grid equals to 2 after the plt text. So that grid lines are shown on the plots. Okay, we have plt.text. Okay, 915, 1550, 1550, 71 India, plt.text 5700 and 80 China. Okay, but they are the word India. So I think it's pointing to the year, GDP, and the life expectancy for those bubbles. And it's going to add the text India on those bubbles. Then I say add plt.good equals to true after plt.text. I'll just copy this. Can I? No, I can't. It's just going to plt dot grid. It's going to add a grid line, I guess, equals to true. And let's run the code. So it's going to add a grid line. So it's going to add Indian and China for the expectation. Then now, interesting. I'm definitely going to copy this code also. and save it in my Jupyter notebook here. So my challenge now is from this code here. Let me just add a file and use a markdown to specify what I want to do here. It's going to be troubleshoots. So I'm going to be troubleshooting this error letter. Troubleshoot error all the way down here. I need to also replicate it in my Jupyter notebook. Now let's see. By the way, if you are familiar with how to solve the error, do let me know in the comment section. I'll be looking out for any help to be able to solve that third variable population error also. So interpretation. Now let's interpret our plots. So if you have a look at your colorful plots, it is clear that people live longer in countries with higher GDP per capita. So no high income countries have really short no high income countries have really short life expectancy, and low income countries have very long life expectancies. Okay, it says no high income countries have really short life expectancy, and no low income countries have very long life expectancy. Okay, still, there's a huge difference in life expectancy between countries on the same income level. So most people live in the middle income countries where difference in lifespan is huge between countries. So depending on how income is distributed and how it is used. So what can you say about the plot? So the countries in blue corresponding to Africa have both low life expectancy and low GDP. Okay, hold on. Let me see that color part. I need to copy the code in that color. Okay, I need to copy this dict. Probably I'll just create this dict later to use to visualize my own data points. Definitely. Can I just paste this dict here? I'm trying to paste more. Okay, what I'm going to do is just add a code here, probably below it. Add a code below it. And just paste my date as a markdown for now and run it. So that's my dict there, my dictionary. Now that's what can you say about the plot? So the countries in blue corresponding to Africa. So countries in blue, Africa's as in blue. You can see Africa is in blue. Okay. Corresponding to Africa have both low life expectancy and low GDP. That's true. You can see African countries. The life expectancy is slightly above 60 and the GDP is less than 10K. That's true. So there's negative correlation between GDP per capita and life expectancy. This is a negative correlation. This is like positive correlation. The higher the GDP, the higher the life expectancy. Okay, China has both low GDP per capita and lower life expectancy compared to India. That's not true. Let's go for the first answer. So the first answer is correct. So up to the next chapter on dictionaries. Oh, I think this is quite long also. This is quite a pretty long from the histogram all the way down to the interpretation. Probably we just focus on the histogram next and we come back for the customization. Let's see. But we just spent slightly 20 minutes above an hour. Okay. So the next chapter is dictionary, which is also way long. We'll probably be breaking it down into 2 live streams, 3 live stream, just to make it easy to consume the number of information. I'll definitely need to solve this my challenge in the Jupyter notebook. Why I'm not getting same results when it comes to this population part before I resume the live stream actually. So I need to solve that before I actually resume the live stream. Okay. So do well to see me after I've actually sorted out this my challenge also. All right, so that will be the end of the live stream. So if you found value learning Python with me, do well to support the channel by giving this video a thumbs up, hit that subscribe button, and let me know if you find a solution to that Jupyter Notebook challenge, the S population, trying to point to the what? to that data point pop using the size in the scatter plot argument. If you find a solution to it, or if you could recommend a video that I could watch also, that I could also solve that challenge, do drop the link under the comment section of this live stream, and I'll be on the lookout and try to solve that challenge also myself. All right, do have a wonderful day. Do well, support the channel, subscribe right now, and I'll see you on day 8. Have a wonderful day. Peace out.